Well, good afternoon, everyone. So my name is Tjorven Delabie. I work at arcsec. Arcsec is a spin-off company of the KU Leuven University in Belgium. We were founded last year, so we're still quite a young company. And we develop attitude determination and control systems for small satellites. So that's basically all we do. That's our focus. So we develop full attitude determination and control systems, which autonomously take care of all the attitude determination and control needs of small satellites. And we also develop standalone star trackers and reaction wheels. And it's really our goal to deliver very high accuracy attitude determination and control systems. On the left, you can see our larger star tracker, which is around 40 by 50 by 95 millimeters. And on the right, one of our new products, the mini star tracker, the twinkle star tracker, which is about the size of a matchbox car and which delivers very high accuracy as well. We have flight heritage on Simba, which is an ESA IOD 3-unit CubeSat, which was launched 1 year ago. The ADCS was fully functional from the start. It contains, well, all the components that we made ourselves. Our reaction wheels work well. The star tracker, as you can see on the right, so this is the overall performance over the entire year. That one has a cross-bore side accuracy of 10 arcseconds, 1 sigma, and the Sagitta that I just showed you will go down to 1 arcsecond, 1 sigma cross-bore sight. So quite high accuracy, and well, it's proven to work in orbit. It's not a sales talk, so I won't go into a lot of details about our components. You can contact me or go to SatSearch or go to our website. So I tried to make my presentation quite educational. So I picked 2 topics to discuss. So rather than giving a lot of more generic hints on selecting an ADCS, I'll be talking 1 about determining the pointing requirements, which I think is an important point, and 2 on integrating, testing, and calibrating ADCS components. I could talk about a lot of things more, and you can contact me and ask questions about it. But so I selected 2 things to discuss in detail, with point number 1 being the one that I will spend most time on. And the reason I chose this point is that there are quite a few sources that can tell you what you can get in terms of ADCS. And I guess everybody who presents here will start their presentation with saying what they can deliver, and you can find it on SatSearch and on other websites as well. But the first question you have actually is what ADCS does my mission need? And I'm going to try to give you a bit of a framework to determine what you need in terms of attitude determination and control system. And it's an important thing, because if you underspecify your ADCS requirements, then your satellite won't be able to do what it needs to do, but well, your ADCS won't be overly costly. But if you overspecify it, then well, your satellite might achieve its point, but the ADCS is overdimensioned and costly. So it's important to find the right specifications for your mission so that you can select the right system. So the pointing requirements that we typically get from customers look like this. So the ADCS shall deliver pointing accuracy of 0.1 degree. And it looks fine. And I guess most of the people who are watching the webinar will probably define their requirements in this sense, but it's lacking a lot of stuff. So I'm going to try to expand this and give you a way of formulating your pointing requirements that will allow you to improve them. So good pointing requirement contains a specified error value. That one is available, so it's 0.1 degree. But it should also specify in which reference frame you define it. So for example, on all 3 axes, or maybe you want it only on 1 axis, and you have on 1 axis and you have less stringent requirements on the other, or you only want it on the payload line of sight. So as an example, I define that it should be half cone along the payload line of sight. It should also have a level of confidence, because if you just say that it should be 0.1 degree, then in theory, it should be that all the time, and your system will be extremely expensive. So here, for example, it's 2 sigma, so 95% of the time it needs to adhere to the requirement. And you should also define which type of error it is. So here it's, for example, an absolute pointing error. It could also be a relative pointing error. There are some others, but they are, I would say, less common. To show you what that actually means, so an absolute pointing error So if you have a system that requires an absolute pointing error, then that's the actual difference between the true and the desired attitude. So that's the big black line on this graph. You can then, over a certain period of time, take the mean of that and define a relative pointing error, which is also called the jitter, which shows the fluctuation around that mean. And to show you what each of those things does, if you have, for example, a disaster monitoring mission, so there's a forest fire somewhere and you want to take a picture of it, you need to have your absolute pointing error low enough to ensure that you're looking at the correct scene. If it's too high, you will be pointing off from the scene you want to see. But even if your absolute pointing error is okay, if you have a high relative pointing error, then you will shake a lot. Let's say, for example, that you take an observation time of 1 second. So typically the integration time of your camera, for example, 1 second, it would generally be lower, I assume. If your relative pointing error is too high, then you will have a blurry picture. So you will also want to define a relative pointing error requirement. What you also need to define is the period in which your requirement needs to be followed. So if, for example, only an eclipse or only during a ground station pass or only during the 5 minutes that you observe a star, whatever. Okay. So once you define your pointing requirements this way, so if you use this framework to define what you actually need, then this way of thinking will force you to think about your requirements in a bit more detail, and it will prevent over and under specification. And in the end, you might end up with 20 pointing requirements instead of the one that you had before, but still it will be better specified and it will not be over specified anymore. And once you've done this exercise on your side, then it will be much easier to select an ADCS system that really does what you need to do. So I look forward to getting like these very detailed pointing requirements from customers. Of course, it's not a sales talk, but you need to sneak in a little bit of sales. This is something that we can help you with. So we've done this for several ESA IOD missions, also for several customer missions. So we can define pointing requirements based on the description of the mission. We can also carry out a pointing analysis to see with which ADCS you can get which accuracy. We can do stability analyses. So those are all things that we've done before and that we can provide as a service. The second point then is, so I talked about pointing requirements, which is something that you need to do at the start of your mission. Towards the end of your mission, once you have your ADCS, you're going to want to integrate it, test it, so commission it. And the point that I would want to make here is that the purchasing cost is often an important driver in the ADCS selection. So if two systems are almost equal, then especially for CubeSats and small sats, the purchasing cost will have quite a high weight in determining which system you choose. But what's often forgotten is that there's a substantial cost linked to manpower, to equipment, to facilities for integrating, testing, and calibrating the ADCS. So once you, if you just get the ADCS in a box at your office, then there's still a lot of work to be done to integrate it. So what I would ask, or what I would urge you to do, is to ask your ADCS component provider, not only to send you the ADCS, but also to provide ground support equipment or software, graphical user interface software, for example, to facilitate the integration. So preferably, you would not only get an ADCS or a star tracker or a reaction wheel, but also the supporting equipment so that you can just, in the ideal world, hook it up to your computer and have a plug-and-play system that you can work with, or get some libraries that you can integrate into your overall satellite system so that you can easily start working with it. What I would also urge you to do is to ask for the functional test procedures and the ability to replicate the acceptance test campaign at your site. So typically ADCS providers will carry out a quite thorough health check test or acceptance test before they send the unit. So I would urge you to ask one for procedures, how to repeat that, and also make sure that you have the ability to replicate those. Because once you can replicate them, then you're quite sure that you can work with the system and you know that you have a healthy system. And as a third one, it's really interesting to have a reprogrammable system, not only in the lab, for if you see that some functionality is lacking, or you would have preferred to have something implemented a little bit differently, but also in orbit. So we recently did a small software update on our ADCS to tweak some performances. And it's really useful if that's possible. So those are three things that I would urge you to look out for. And also to take into account is that this can greatly reduce your development time, project cost, and also just make you a happier person. And of course, all of this is standard included in what we deliver. So I haven't made it a very long presentation, so I just focused on 2 points. One is on helping you to determine your pointing requirements. So yes, make your requirements less dumb is something that we hear a lot. And the idea that I want to give you there is that if you use the correct formulation for these requirements, then you will get your project right from the start. And for integration, testing, and calibration, take into account that it's an important cost driver. So ask your ADCS component to give you as much support as you can get. And that was it from my side. So if you have any questions, you can contact me. Thank you.